Hi everyone. So today we will solve LeetCode 796. It's called rotate string. So in this question we are given two strings s and goal, and we need to return true if s can become goal after some number of shifts on s. So by shift we mean that in one shift we move the leftmost character to the rightmost position. That is, for example, suppose we had a string s which is ABC. So if we shift it by one position, we perform one shift. So the leftmost is this, right? The A. So this after one shift, the A goes to the last position, and rest characters remain as it is. So this is meant by one shift. Suppose we had something like D, E, A, F. So if we perform one shift, we would get this is the leftmost, and it would go to the rightmost position. So E, A, F remains same and D goes to the rightmost position. So this is the string after shifting it by performing one shift. So I hope you understood what the shift means here. So we are also given two examples. So let me first, tell the first example. So we have something like A, B, C, D, E. So, and we need to check whether we can reach this goal or not by performing our shifts. So let's shift it by perform one shift. So B, C, D, E remains as it is. And since A is the leftmost, it goes to the rightmost position. So we get this. So we match this. It's not equal to our goal, so we still perform another shift. Now B is our leftmost. So C, D, E, A remains as it is, and B goes to the rightmost position. So B comes here. And now you can see both of them match. So that's why we return true, because we reached our goal, that is this, by performing shifts, two shifts. Similarly, in the second example, you can see we had something like A, B, C, D, E. So if we perform one shift, you would get something like B, C, D, E, A, right? It's not equal to goal. So if we again perform the shift, we will get C, D, E, A, B. Again, it's not equal to our goal, so again shift D, E, A, B, C. Again not matching, so again shift. So this is the leftmost, it goes to the rightmost. So we get this. Again, it's not matching, so let's shift it once more. E is the leftmost, so it goes to the rightmost position. Again, it's not matching. So you would see that we reached our initial string again. That means we tried all the possible shifts and tried every combination we could have made, but still we didn't, matched with our goal. So that's why we return false. And here's one more thing you would observe. Here array length was 5, string length was 5, right? So you would see we performed one, two, three, 4, and 5 shifts. And after 5 shifts, we got the original string. So this means if a string S has length n, then if we performed n shifts, that is the number of shifts of this, which is same as the string's length, we would again get back the original string. And it makes sense also. So yeah, we would try performing the shift n times, that is the string's length time. And if after that also we didn't get, we matched with our goal, we return false. And in the meanwhile, if we get any place we match with our goal, we return true. So I hope the question is clear. So let me come to the approach. So coming to the approach, let's consider this example. So see, the hair length is 4, right? So we are sure that after even performing 4 shifts, even still, if we are not getting reach our goal, that means we would never be able to reach our goal. So that is when we will return false. So if we perform all the shifts, we would get something like in first shift we would get this. Then B goes to the rightmost, so we get C, D, A, B. Then C goes to the rightmost, we get D, A, B, C, and D goes to the rightmost, and we get A, B, C, D. So as you can see, after performing four shifts, that is the string's length shifts, we reached our initial string again. So let's see if we matched in the meanwhile or not. So here you can see we didn't match with our goal. Here, here you can see we matched with our goal. So that's why we return true. So I hope you understood the approach. So you would do nothing, but you would run a loop that will perform shifts n times. So we can take a variable name shifts and we would perform shifts equal to n times. That is a string's length time. And every time we would increase shifts plus plus. So, and also to shift, what we can do is C. We initially had A, B, C, D, right? So by shift we mean we place the leftmost character to the rightmost position. So for this what we can do is we can extract this substring, that is the substring from, and let me index it, it's 0, 1, 2, 3. So we keep all the remaining characters as it is. So this thing is kept intact at every shift. That is from first position to the last position, which keep our string intact in every shift. So we can extract this thing first. So this can be extracted by s dot substring 1. So it does nothing, but it gets the substring from the first index to the last index. That is starting from 1, it gets all this. So this would give BCD in our case. And we know we need to append the leftmost character to the rightmost position. So what we will do it, and we already have the remaining characters. We now just only have to append the leftmost character, which is A, to the rightmost position. So we can simply do s dot substring 1, which we already have this, that is the remaining characters, plus the first character, that is the leftmost, which is nothing but s dot char at 0. So every time we would do this, and this would give our resultant string after performing the shift. So I hope it's clear. So every time we would change our string to s dot substring 1 plus s dot char at 0. So if I explain again, suppose we had ABC and index it, it's 0, 1, and 2. So s dot subs, if you want to shift it, we do s dot substring 1. S dot substring 1 means starting from one index, we take the entire substring. So we get s dot substring 1 gives us BC in this case, plus s dot char at 0. Char at 0 is A. So char at 0 is A, so we get CA. And if we join these, we get BCA, which is indeed our resultant string. If we've performed one shift in it. So I hope this logic is clear. So you would every time do this, write this statement, s is equal to s dot substring 1 plus s dot char at 0. And if it matches with our goal, so you would check if s dot equals goal, then we would return true. And the loop ends here. And as I told you, if we performed n shifts and still we didn't reach our goal, so we would never reach it again. I mean, we wouldn't never reach it. So we would directly return false at the end. Since we cannot reach our goal even after performing n steps also. That's why we return false at the end. So this was the first approach coming to the time and space complexity. So space, every time we are modifying this, but this is this was given to ourselves. at the initial stage only, the input string. It's nothing but the input string. So we are using the input string also, only modifying it so we can consider the space complexity as big O of 1. However, it is not true because, as I've already told you, that strings internally occupy more space as they are, immutable in nature. So every time we do modifications in string, like we are doing this, so the changes does not happen in the original string. Suppose this is our original string. It's not like that we edit it and it becomes something else. Whenever we modify a string, it's not replaced in this, rather a new copy is created, and in that the modification is done. So that's why we can treat it as big O of 1, but internally it's not big O of 1, it is larger than that. And same with the time complexity also. So every time we run a loop for n times. So time complexity is big O of n, but internally again string operations due to their immutability take larger time. So it's almost n square. So this is our time and space complexity of our first approach. Let's head over to the second approach, which is an even better approach, not complexity wise, but yeah, it's an observation based approach. So coming to the second approach. So see, here if we perform our shifts, we would get B, C, D, A. Then again, if we do it, we get C, D, A, B. Then D, A, B, C. And then again, we get A, B, C, D, which is our initial string. So, and here we match with our goal, so we return true. So, see, in the previous code, we, by using substring, we, devised all these strings we can have after performing our shifts. But here's a smarter observation. Suppose we concatenate the original string to itself. So let me show you what we get. So S was initially A, B, C, D, and if we concatenate itself to it, so we would get something like ABCD plus ABCD. So which is nothing but ABCD, ABCD. So this is S plus S. So now what we will do is, now let's observe one thing, which is a very smart observation. So we consider every position as a starting index. Like this is also can be a starting index, this can also be a starting index, like this every position. And we know our goal is of length 4, right? So first we go here. So our goal is of length 4, right? So if this is the starting position, we can go up to 4 places. So this is our first string, which can be formed, which is nothing but the initial string itself. That means if we performed 0 shifts, we would obviously get the first string itself. Now, if you look at this, now one can, considering 1 as the starting position, we would get 1, and goal is of length 4, so we go up to 4 places. So we get this as our second string. And as you can see, this is nothing but a second string which we got after performing one shift. So I hope you are getting the idea what I'm saying. Now considering 2 as the starting position, we start with C and we can go up to 4 positions since goal length is 4. Now we get CDAB, which is nothing but this. That is the string we got after performing another shift on this string. Now again, if we do something like we take 3 as a starting position, we would get DABC, which is nothing but a third string which we got after performing shift on this. And finally, if we take index 4 as a starting position, we would get A, B, C, D, which is nothing but a last string, which is the initial string itself. So that's not needed, but still if we are doing this, so we check with this also. So what you can see is what I'm trying to say. By concatenating S to itself, we automatically got every string which we were getting after performing our shifts. So this is the observation. So if our goal can be reached, we are always sure that it would definitely exist in this S plus S string. I hope it's clear. Because as you can see here also, we have DABC and it does exist here, DABC. So if our goal can be reached, it would always exist in the S plus S concatenated string. So this was the second approach. Its code is very simple. It's just a one-liner code. So you would directly return. Also, we would put this check also if suppose s dot length should also be equal to goal dot length, because if suppose our string is ABC but our goal is AB, so it can never be reached, right? Because performing shifts does not change the number of characters we have. So if we perform a shift, characters will always be three only, which is the initial length. So it can never go to two characters. So that's why for a goal to be matched with our string after performing shifts, its length must necessarily be equal to the initial string. That is our input string. So this is the one check we put, and we also saw that our goal should be present in s.s. So I already have told you to check whether a string is contained in another string or not. Use the contains function. So we do nothing but we write s plus s. If it contains our goal, then we directly return true. So this is the one-liner solution for our problem. So I hope it's clear. So coming to the time and space complexity, time complexity is again n squared due to internal string operations because string is immutable. And space complexity, we have created a string of s plus si. So if we consider string s of length n, so space complexity is length of s plus length of s, which is n plus n, which is 2n, and asymptotically it's equal to big of n only. So this is a time and space complexity of our approach. So I hope it's clear. So yeah, this was it for today's video. Thank you so much for watching.